Alright, welcome to our review for Finite Math Exam 3. Let's go ahead and get started. So first up, we are interpreting some sets here. So A is a set of people with blue eyes, B is a set of people with brown hair, and we want to write the symbolism in words. This first one is A intersect B, and remember the key word there is AND for intersection, and this looks like an N. Down here, this one is union. Remember, that's an OR, and union looks like a U. The union symbol looks like a U. So this set is going to be the set of all people that have blue eyes and brown hair at the same time. So this is a set of people with blue eyes and brown hair. And so that one wasn't too bad. Now next up though, we've got a union here, and it's inside of a negation. Remember, the prime is not. That's a not. So if we just had the union, this would be the people with blue eyes or brown hair. So all the people that had one or the other or both. So this is a not outside an or. So remember, not or you can interpret as a neither. So one way to say this is that this would be the set of people see if it's not the case that they have blue eyes or they have brown hair, then they'll have neither. So this is a set of people with neither blue eyes nor brown hair. Now probably a little bit more precise way to say that would be this is the set of all people who are not those that have blue eyes or brown hair. So that would be equivalent to do a not or, not the set of people that have one or the other. And then let's see, next up here we need to do some graphing in a Venn diagram. So we want to shade the region in the Venn diagram representing, and it looks like we are missing a symbol here. This actually should be a union. For some reason that did not print correctly. So this is not A or B and not C. So why don't we do this in steps, and I included a couple of diagrams here for you. And actually in our next problem we could use one of these guys. Go ahead and take that down there. Okay, so let's start by looking at this part here, the B and not C, or B intersect not C. So we want the overlap of B and not C. So let's take B and shade like this, and then take not C and shade like that. So, well, let's first label our sets. So let's call this A, B, and C. And then we're going to take B and shade like this. So here's our set B. Line tool is giving me a little bit of problem here. There we go. Okay, so there's the set B, and then not C, so everything that's outside of the circle C, we're going to shade the other way. Everything that's outside that circle. So when I'm doing this on paper, what I like to do is I like to cover up that circle C with my thumb and then shade everything that's outside of it. So there is not C. And then the intersection here, remember that's the overlap. Okay, so this is going to be the overlap or the intersection of B with not C. So you can see that the part that's crosshatched is this sort of crescent moon right here. Okay, so why don't we take that and shade it over here. So this is our B and not C. And then we want to unite that with A prime. Okay, so why don't I label our sets here again. So here's our A, here's our B, and here's our C. And everything that's inside of A is going to be this circle. And then we want to unite that, do an OR with not A. So take everything that's outside of A and unite it with the orange area. So everything that's outside of A is going to actually include some of that orange area. Let's go ahead and shade that. Why don't we shade that with horizontals here? So like this. So everything that's outside of A we shade horizontally. Okay, and then we're uniting, so we're going to keep the horizontal shading and we're going to keep the orange shading. So we would want to shade all of this in as our final answer. So our final answer is going to be all this stuff out here. It's going to be this part here, the B. And all of this here. Because that is all outside of A, and that piece too, and that little guy there too. So that's our final answer. Okay, next up we've got a counting problem. So let's see, we've got 270 area voters, and we're looking at their views on taxes, the deficit, and abortion. So let's go ahead and label some sets over here. We've got 3 things we're asking about. Taxes, let's label that that set T. So the people that favored lowering taxes, those that wanted to reduce the deficit, let's label that set D for deficit. And let's see, those that favor abortion on demand, let's label that A. Okay, so these are all in the positive. So we want to lower taxes is T. We want to reduce the deficit D. We want to allow abortion on demand A. And let's go ahead and label these sets. So here's T and D and A. And then what we want to do, remember, is we want to label all these little pieces in here using the information here. So we can only do one piece at a time though. So if you have information in here that you can't use immediately, then just bypass it and keep going. So 70 favored lowering taxes, not reducing the deficit, and we're against abortion. Okay, so this is favored lowering taxes, so that's T, not the deficit, so and not D, so D prime, and against abortion, so and A prime. So this is telling us the amount that was in T, but not in D and not in A. So you're inside the circle for T, but you're not inside the circle for D, and you're also not inside the circle for A. So that's kind of saying the people that only wanted to lower taxes, so we can actually fill that in. That is this part right there. Okay, that's the 70. So let's go ahead and label that. And then 80 favored reducing the deficit, so that's D. Not lowering taxes, so and not T, T prime, and against abortion, so and not A. So this is saying you're inside the circle for D here, but you're not inside the circle for T, and you're not inside the circle for A. That means that you're in this part out here. You're only D. So that's 80. Oh, and let's check these off as we go. And actually, let's write the number symbol beside these. So the number in there was 70. And then the number that were in D, but not T, not A, was 80. And then 65 favored abortion on demand. So that's not saying only abortion. That's saying 65 is this whole circle, which has got 4 pieces. So we can't use that yet. So let's keep going. 45 lowering taxes and deficit at the same time. So, well, let's write this out in symbols here. So this is the number for A, and that was 65. Haven't done that one yet. This is going to be taxes and deficit at the same time. So that's T intersect D. So T overlap D. That's going to be these 2 pieces here. Can't do that yet, but that's 45 total. 35 lowering taxes and deficit, but not abortion. Okay, so this is taxes and deficit, but not abortion. So and not abortion. And that number is 35. So taxes and deficit, that's this football here. But then it says not abortion. So it's the part of this football that's not inside the circle for A. That's this little piece here. So that's got to be 35. So we use that. And then we can go back up here now and we can see, oh, taxes and deficit, that's 45. Okay, that was the whole football is 45. This much is 35, so this has got to be 10 in there. Okay, so that one's used. So we kind of use these, if I number like which order we did these in, so we could do that one, did that one first, we did this one second, then we had to come down here, we did this one third, and then this we got fourth. Okay, now we still can't do, still can't fill in the pieces around abortion because there's 3 pieces with this 10 that have to total up to 65, so out of luck there, got to keep going. 25 favored reducing the deficit and abortion, so that's the number in D and A, it's the overlap. So D and A, that's this football here. The total of that is 25, so this is 25. We've got 10 in the middle, this total football is 25, so this is 15. So that's the 5th piece of information. Still can't fill in A because we've got 2 pieces there. 30 favored abortion on demand but not lowering taxes. So that's the number that are in A and not lowering taxes. So and T prime, not T. So they're inside the circle for A, but they're not inside the circle for T. That total is 30. And so that's actually these 2 regions here. Well, this one's 15, the total is 30. This has got to be 15 here. 15 and 15 make 30. So that we used, and that was the 6th piece of information. And now we can use this total that favored abortion on demand was 65. So the total of this whole circle is 65. 15 and 15 is 30. 10 more is 40. So that leaves 25 in here to make this 65. 65 minus the total of the rest. And so we use that piece of information 7th. And then the only thing that we haven't used is we surveyed 270 altogether. So 270 is represented by this whole square, everything that's in there. So to get this part out here, outside the 3 circles, we do 270 minus the total of what's inside there. So if you total up everything that's inside here, let's see here, we've got 70 and 35, that's 105. 115, 120, 140, and 30 is 170, and 80 is 250. So 270 minus 250 gives us a total of 20. So this region on the outside, that's outside all 3 circles, 20 people in there. Alright, so now let's answer the questions here. So how many people were against all 3? So that's asking what were the number that were in, let's not start with A, that were in not T and not D and not A. So they're not in the circle for T, they're not in the circle for D, and they're not in the circle for A, all at the same time. So you're outside this circle, outside that circle, outside this circle. Oh, that's the 20. And if the symbolism doesn't help you, that's okay. So you don't have to write that, but I'm trying to, put this in symbols and do that translating back and forth because I ask you to do some of that in some of the earlier problems, like this one. Okay, we do some translating the other way. Next question, how many people favored abortion but not lowering taxes and not deficit? So this is asking about abortion and not taxes and not deficit. And they want to know what's the number of people in there. So that's inside the circle for A, but they're not inside the circle for T and they're not inside the circle for D. That's this 15 here. So that's 15. So again, as you go through here, if you can't use the information, keep going until you find something you can use, check it off, and then fill in. Sometimes you're working from the inside out. Here we kind of work did a little bit of both. From the outside, got these 2 outside, and then started working on the inside. Just depends on how the information is given to you. All right, next up, we're switching gears. We're going to probability here. We toss a coin 3 times in a row, and we want to list the sample space. So there's 3 steps in this experiment because you're tossing 3 coins. So we don't want to use an outcome table. We want to use a tree diagram to do this. So your first toss, you can either get heads or tails. And then your second toss, if you get heads on the first, you can either get heads or tails on the second. If you get tails on the first, you can either get heads or tails on the second. And then each one of these, the third toss here, if you get heads on the first, heads on the second, third toss, you can get heads or tails. So each one of these will have a heads-tails split coming off. And then to get the different outcomes, you just follow the branches down to the end. So here we've got heads, heads, heads. That's first, second, and third toss here. So we can represent that as HHH. Heads on the first, heads on the second, tails on the third, so HHT. Heads, tails, heads. And we keep going here. Heads, tails, tails. Tails, heads, heads. Just follow those branches down to the end. Tails, head, tails. Tails, tails, heads. And tails, tails, tails. Okay, so this is a list of the outcomes. So here The way I phrased this, I said list the sample space. Now the sample space is the set of outcomes, so the sample space S is actually the set of all the outcomes. So heads, 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 all the way down to tails, tails, tails. So now if I just said list the outcomes that are in the sample space, then you'd be good here. Those are all the outcomes. But here I'm actually saying find the sample space, or list the sample space. So, and the sample space is a set, so remember to put those into set brackets. So, and then if this was a two-step process, then we could do it with an outcome table. And in fact, that happens in number 5. So here we've got a die that's tossed twice. We're recording our tosses as ordered pairs. And then we want to represent the event that the sum of the tosses is less than 6 as a subset of the sample space. So, and here I'm really asking you to list it as a subset. So we have to list a set of values here. So the easiest way to do this is to make an outcome table. So your first die can go down the side here. So 1, 2, 3, 4, 5, or 6 on the first die. And then outcomes for the second die across the top. 1, 2, 3, 4, 5, and 6. So this is your first die. And then over here's your second die. And so our outcomes, 1 on the first, 1 on the second, 1, 1. 1 on the first, 2 on the second, 1, 2, and etc. Just go ahead and fill in our outcome table here. Okay, and I'm going to go ahead and fill in the rest of this. Ta-da! Okay, so that's what our outcome table looks like. And yeah, I was writing so fast you didn't even see the pencil moving, did you? And so we want to now represent the event. The sum of the tosses is less than 6. And remember that the sums are constant on these cross diagonals here. So sum of 2, sum of 3, sum of 4, sum of 5, and sum of 6. And we want our sum to be strictly less than 6. So let's see, that's going to go down to this diagonal here. So that's going to be the outcomes inside that triangle right there. So our event here, we'll call it E, then is going to be 1, 1, 1, 2, dot, dot, dot. So down this row, all the way to 4, 1. Okay, and if you've got all of the outcomes circled and you abbreviate here with the dot, 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 that's okay. We're good. Now, I could also ask you some things about, probabilities of things happening in this table. List different events. So, for example, what is the probability of this event? Well, remember, probability is desired outcomes out of total outcomes, and there are 4, 3 is 7, 8, 9, 10 outcomes in there. So there's 10 outcomes out of 36 in the table. So 1036 would be the probability of that event. And then let's say I make another event here. Let's say that F is the event doubles. Okay, let's circle that guy in blue. So our doubles are right here. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. And then I could ask you, for example, what is the probability of E and F happening at the same time? So that's everything that's going to be circled in black and circled in blue, which is just 2 outcomes. Okay, so this is 2 out of 36, or 1/13. And then I could ask you, for example, what's the probability of E or F? So what's the probability that the sum is less than 6 or they're doubles? Well, it's going to be these 10 outcomes and then add in these 4 more. So you unite the two sets, but these two already got counted with the 10 that are circled in black. So you got 10, 11, 12, 13, 14. 14 out of 36. And then we're doing some more basic probability rules with the deck of cards here in problems 5 through 8. And I will have a deck of cards available for you in case you are not familiar. So first of all, we want to find the probability of a diamond. And so if I go to our deck of cards here, so there's our deck of cards. Remember that there's 52 cards total here, and there are 13 of each suit. So 13 clubs here, 13 diamonds, 13 hearts, 13 spades. So back here, probability of a diamond, there are 13 diamonds here out of a total of 52 cards. So this would be 13 out of 52, which reduces to 1/4. 13 goes into 52 4 times, or if you just divide that out in your calculator, 0.25. Probability it's a king or an ace. Okay, so let's so we want to do probability that it's a king or an ace. Okay, so 2 ways to do this. We can find the union of the two sets and count the outcomes in there and put it out of 52. Or we can use the addition rule, because union is addition, or is addition. So let's first count. So kings or aces. So our kings are here, 1, 2, 3, 4 of them. And our aces are here, 1, 2, 3, 4 of those. So 8 out of 52. So that's if we count directly. Or we can use the union rule, which says, hey, take the probability that it's a king and then add the probability that it's an ace, and then subtract the probability of the overlap, king and ace. Okay, so probability it's a king, there are 4 kings out of 52, plus probability it's an ace, there are 4 aces out of 52, and probability that's a king and an ace at the same time can't happen, -0. So that still gives you your 8 out of 52. So that one, it was probably easier just to count the outcomes. Here, a king or a black card. Okay, so probability that it's a king or black. So I'll use K for king and B for black. So again, we can either count outcomes or we can use the union rule. So let's try counting outcomes first. So king is these 4 cards, and then the black is these 13 here and these 13 here. So, well, if we take the black cards, 13 plus 13 is 26, and then we unite that with the kings, these 4 cards, well, the king of clubs and the king of spades have already been counted in the 26, so we've got 2 more to add in, so 27, 28. So in the union there are 28 cards out of 52 that are either kings or black cards. Now the other way to do that is to say, well, this is the probability that it's a king plus the probability that it's a black card, and then subtract out the probability, that's a P, probability that it's in the overlap, that it's king and black, so a black king. So probability it's a king, there are 4 kings here out of 52 cards, so 4 out of 52. And let's see here, we are going to add probability it's black. Well, half the cards are black and half are red, so right, 13 and 13 is 26 black cards, so plus 26 out of 52, and then subtract out the black kings. So there's 2 black kings, the spades and the clubs, because they've already got counted once here in the black cards. They got counted twice when you count the kings, so you have to subtract them out. So minus 2 out of 52. So we've got common denominator here. Just add our numerators. 4 plus 26 is 30. Minus 2 is 28 out of 52. So either way, we get that same 28 out of 52. And looks like some of these guys are reduced. That's also, if we divide top and bottom by 2, that's 14 out of 26. Which is also 7 out of 13. Which is A. Oh, and I forgot to mark up here the 8 out of 52. Let's see, that would be the same as 4 out of 26 or 2 out of 13. So that's actually going to be in none of these in number 7. And then last up here, probably it's a black face card. So the face cards are Jack, Queen, and King of each suit. So there's 3 face cards times 4 suits, 12 of those. And we've got 3 black up here, 3 black down there. So 6 black face cards. So this is asking, what's the probability that it's black and a face card at the same time? That's 6 out of 52. Which is, if we reduce that, 3 out of 26, which is C. Okay, now let me ask you a few other questions here real quick regarding these problems. So we haven't done a negation in there. So what if I ask you, what's the probability that it is, say, not a diamond? Well, the easiest way to do that is to count the complement and subtract from 1. So this is going to be 1 minus the probability that it is a diamond. And the diamonds there are 13 diamonds here out of 52. So this would be 1 minus 13 out of 52. And now we can get a common denominator here. This 1 is 52 out of 52. Just multiply top and bottom by 52. Minus 13 out of 52. And that's, let's see here. $39 out of 52, which is 3/4, 0.75. So there it's easier to count the complement. And then if you have 2 negatives in there, then you may want to use a De Morgan's law. So for example, what if I ask you, what's the probability that it is not a face card? So let's let F be face card, not a face card, or not a club. Okay, so that's a little harder to count this, okay? Because not a face card is saying it's not one of these 12, or not a club, it's not one of these 13, and you want to unite those 2 sets. So we think about that a little bit. We can decide what that is, but there's a little bit easier way to do it. So let's write this in symbols. This is probability that it's not a face card, let's call that F prime, or is a union, not a club, let's let C stand for club, so not C. So here we've got 2 negatives and a union in between, so then we can use one of those De Morgan's laws. So remember De Morgan's laws, I had put those on the study guide for you here. Let's see here. Yeah, right here. Okay, so complements of unions and intersections. So, actually this should have a prime over it. I'll have to fix that. So this should be the complement of the intersection is the union of the complements, and the complement of the union is the intersection of the complements. Okay, well ours is the union of the complements. So that looks like this right-hand side. So that's going to be, again, there should be a prime right here. That's going to be the complement of A intersect B. So in our case, this is going to be the probability of the complement of F intersect C. And the probability of the complement is 1 minus the probability of the set F intersect C. And this is a little bit easier to count because this is 1 minus the probability that it's a face card and a club. Face cards and clubs, that's not bad to count here. So here's the face cards. And the face cards that are clubs, just those three there. Jack, Queen, and King of clubs. So we're not allowing those. So face card and club is 3. We're going to subtract those out. So 1 minus 3 out of 52. And again, write this as 52 out of 52. So this is 52 minus 3 out of 52. So that's 49 out of 52. So again, if you get these double negatives here, or if you get a negative outside a union or a negative outside an intersection, then you want to go back and you want to use one of these De Morgan's laws. And again, this is prime. The prime of A intersect B is A prime union B prime. Okay, we're doing some of the same things again with probabilities, except now we're given a table of data instead of looking at the actual objects that we're trying to find probabilities of. We're going to look at rows and columns. So here, remember, the key idea is to name your events and then try and circle rows or columns that fit what you're looking for. So, for example, find the probability that a person is not a freshman or they prefer cheese. So let me write that in symbols. Freshman, we can abbreviate that as FR. So they're not a freshman. So that is not freshman. Or is a union. They prefer cheese. So union C, let's let C represent those that like cheese, M for meat, and V for veggie on their pizzas. Okay, so this is everyone that is either not a freshman or they like cheese pizza. So we're uniting those two sets, we're putting them together. So people that are not freshmen, so we're not freshmen, so we're not in that first column. So we're either sophomore, junior, senior. So that's these people here. So that's not freshmen. Or they like cheese. So cheese is the first row here. Okay, so what we want to do, since we're uniting, we're going to put those two sets together. So we're going to take the 66, the 34, and the 35. And we're going to unite that with the 11 that did not already get counted. So that's the easiest way to find that probability. We could also use union rule, but it's going to be more work because not freshman is going to be everything that's inside here, and then you'd add cheese, which is this whole row, and then you'd subtract out the overlap, which is the 14, 20, and 13. But it's easier to just unite the two sets without the double counting. So that was going to be 66. These three columns are not freshmen. So 66 plus 34 plus 35. So that's the sophomore total, junior total, senior total, and then only the 11 did not get counted in those totals. So plus 11. And then total outcomes is 181 that we surveyed. So desired out of total. And that gives us 146 out of 181. And it's okay to just leave that as a fraction. What's the probability a person will prefer meat given that, some keywords there, given that, this is a conditional probability then, they are a freshman or sophomore. So let's write this in symbols. So this is, we're finding the probability that they prefer meat, so that's M, given that they're freshman or sophomore. So freshman or union sophomore. Okay, so it's given that they're a freshman or sophomore. So it's given that they're in one of these two columns. So, whoops, not one of those two columns, one of these two columns here. Okay, they're either in the freshman column, which is at 46, or they're in the sophomore column, which is at 66. So remember that your given condition determines the denominator of the probability. So this is going to equal, in the bottom, 44 plus 66. I'm sorry, 46 plus 66. And then out of those two columns, the 46 and the 66, we want to know how many of those people like meat. So that's your desired outcome. So out of the 46, 15 prefer meat, and out of the 66, 22. So those are going to be up here in your numerator. So 15 plus 22. So that's 37 out of 112. And then let's do one more example. Let's get a negation in here. Just to give you one more example. What does the probability say that the person doesn't prefer veggie pizza if they're, say, not a senior? So if we know, so those are keywords again telling us a conditional probability. If we know they're not a senior. So this is asking what is the probability of they don't prefer veggie, so not veggie, so that's not V. Given that, because if we know is telling us it's a conditional probability, so we've got a given condition that they're not a senior. So that's going to be given that not senior, so senior prime. So the given condition here determines the denominator of the fraction. So that's our total outcomes. So if they're not a senior, they're not in this column, then that means they're either junior, sophomore, or freshman. So 46 plus 66 plus 34. Okay, which is all of these numbers here. So out of those 9 numbers, we want to know how many of those people do not prefer veggie. So the veggie out of those people is going to be 20, 30, and 4. So not veggie is going to be the 11, 15, 14, 22, and 20, 10. So this will be 11 plus 15 plus 14 plus 22 plus 20 plus 10. Okay, because it's given that they're in here, and then out of those, how many are not in the row for veggie, which is these 6 numbers here. Which is going to be, let's see here, 10, 20, 30, 50, 70, 82, 83, and 9, 92 up on top, and then downstairs 40 and 60, 130, 46. 92 out of 146 would be that probability. So, and again, you don't have to use the symbolism that I did here, but I think you'll find it helpful to circle columns and rows and then think about, are you uniting or are you doing an overlap? Actually, I didn't do an overlap probability here. For example, what's a probability that they are not a sophomore and they like meat? Okay, so the not only goes with the sophomore. So this is asking what's the probability of S prime intersect M? So that's saying, okay, well, look at all the people that are not sophomores. So let's put those people in blue here. So not sophomores is going to be those people there, which is the 35 and the 34, and also the 46 right there. And then what we want to do is we want to overlap those and say, out of those people, the people that are in blue, how many people also prefer meat? So let's do that in red. Red meat. Okay. So we want the people that are both inside the red and inside the blue. So that's 15, 10, and 10. So that's going to be our desired outcomes. 15 plus 10 plus 10. And then our total outcomes, this is not a conditional probability. This is just asking an overlap. So that's going to be out of the 181. So that gives you a couple of extra examples there that give you an idea of how I could vary the problem. All right, and then we are winding up here with some tree diagrams here. So 2 marbles are drawn without replacement. That's important. From a box that contains 3 white, 2 green, 2 red, and 1 blue. Find the probability that you get 1 red marble and 1 green marble in any order. Okay, so one thing that you can do to help you visualize here is you can actually draw your marbles, get a visual picture here. So let's see, there's our 3 white, and then we got 2 green, and 2 red, oops, so 3 white, 2 green, 2 red, and 1 blue. Okay, so let's color these guys here. So we had 3 white, 2 green. So here's our 3 white, 2 green, 2 red, and then 1 blue. Okay, so there's our marbles. And they're in our box here. And let's see, we want to find the probability that we are going to draw 1 red and 1 green in any order. So there's 2 ways that this can happen. We could either draw a red and then follow that by drawing a green, or we could draw a green first and then follow that with a red. Now, there's lots of other outcomes in here because there's 4 colors. There actually would be a 4-way split on the first branch, and then a 4-way split on each of these second levels. So you'd actually have 16 branches. But these are the only 2 that we're interested in, is red green or green red, because it says 1 red, 1 green, any order. Okay, so we only need to draw, in this case, the branches of the tree diagram that we're interested in. So this level is first draw, and then this level is second draw, and remember it's without replacement. So first draw, there are 2 red marbles out of a total of 3, 6, 8. So this is going to be 2/8 probability. And then the probability of green on the first, there's 2 green marbles out of 8 total, so that's 2/8. Now on the second draw, you've got 1 less marble. So here you drew red on the first, so 1 red marble's gone. And so you're asking, what's the probability of getting green on that second draw? Well, there's 2 green marbles out of 3, 4, 5, 6, 7 left. So this will be 3/7. And then if we draw a green first, then one of those green marbles is gone. And we're asking what's the probability of getting a red on the second draw? Well, there'll be 2 red ones out of 7 that are left in there. So that's also 2/7. You know what? Did I say 3? Sorry, I said 2 and I wrote 3. Here, if we draw a red one out first, 1 red one will be gone, and we'll have 2 green ones left out of 7. Sorry about that. That should be 2/7. And then remember our different outcomes here, red, green, and then green, red. To get the probability of those outcomes, you multiply on the branches. So this will be 2/8 times 2/7. So that's 4 out of 56. And the same down here, 2/8 times 2/7. So that's 4 out of 56. And then to get one green and 1 red means we could get red green or green red. So we want the probability of red green or, which is a union, add green red. So this is going to be add the 2 probabilities by the addition rule. Remember, addition rule here, let's see here, right here, union rule or addition rule. Probability of E or F is the probability of the 2 events, subtract out the overlap, or if they're exclusive here, then you're just adding the 2 probabilities. And for us, these are exclusive because you can't get red first, green second, and green first, red second at the same time. So we just add these guys up. So 8 out of 56. And then to finish up, we are drawing 2 cards. So here you're dealt 2 cards, again without replacement. So that decreases the amount available in the second draw. From an ordinary deck of 52, use the probability tree to find the probability of drawing 1 or more kings. Okay, so first we want to try and name some events here. And notice on this one it says draw the probability tree showing all possible outcomes from the 2 draws and find the probability of each outcome. So you got to show everything. Whereas here I didn't say that, so you just need to show what you needed. So on that, let's let our events here be king. K stands for king. And then if it's not a king, anything else we'll just call K prime. It's not a king. So whatever other card that it is, we don't care. It's not a king. So on our first draw here, we could either get a king or something else, not a king. And if we draw a king first, we could either get a king on the second draw or not a king. So this is second draw. And then if we don't get a king on the first draw, we could get a king on the second or not. So our outcomes here are king on the first, king on the second. So that's K and K. Or king on the first, not king on the second. K and K prime. Or not a king first, king on the second. So it's K prime K. Or we could draw 2 cards that are both not kings. So K prime, K prime. And then let's go ahead and fill in probabilities on this diagram. So kings, remember there are 4 kings out of 52 cards. And then this is all possibilities on this branch. So this has to be the other 48 cards out of 52. So that these add up to 52 out of 52. Now on the second draw, we've drawn without replacement here. So there's only 51 cards left. So we can fill in the denominator 51 on all these. All these draws are out of 51 on the second card. And here if we've got 4 kings on the first draw, we draw one of those out, we've got it in our hand, then there are 3 kings left for the second draw. And then there are 48 cards that were not kings. We didn't take any of those away, so this is still 48. And notice 48 and 3 adds up to 51, the denominator. Now, if we draw a card here that's not a king first, we took out one of those 48, so that means for the probability of not king on the second, there's only 47 cards left. But we didn't take out any of these 4 kings, so there's still 4 kings out of 51 left on the second. And now we multiply down the branches to get our probabilities. So king and king, that's going to be 4 out of 52 times 3 out of 51. King, not king, 4 out of 52 times 48 out of 51. Not king, king, 48 out of 52 times 4 out of 51. And then if they're both not kings, 48 out of 52 times 47 out of 51. Now, if you want, you can do all of these in decimals, and I'd round them to, at least 3 decimal places. So you've got percentages to 1/10 of a percent. So for example here, if you multiply these straight across, 12 out of 52 times 51, that's approximately 0.006. And then 4 times 48 out of 52 times 51 is approximately 0.072. And then same thing here, notice same numerator, same denominator, orders just switched, so that's about 0.072. And then 48 times 47 out of 52 times 51 is about 0.851. And then we want to know what is the probability of 1 or more kings here. So the probability of 1 or more kings. Well, here we've got 2 kings, so we're going to include that probability. Each of these cases we've got 1 king, so we're going to include those probabilities. Here we didn't get any kings, so we don't include that. So we're going to add these 3 probabilities here. So this is going to be 0.006 plus 0.072 plus 0.072. And actually, that 0.006, I rounded that the wrong way. That should actually be 0.005, and then here also, if you round that to the nearest tenth. It's like 0.0045, so it'll round up. And so if we add these guys up, let's see, this is 14.4 and then another 0.005, so let's see, 149, so 14.9% chance that you'll get 1 or more kings. Now the other way we could have got that is we could have said, hey, let's just take and subtract this 0.851 from 1. So we could do 1 minus the complement event, which is no kings. So 1 minus 0.851, which is also 0.149. So 2 ways to get that. And then always remember that these probabilities here should add up to approximately 1. And these add up actually to exactly 1 with the rounding. So this adds up to 1.00 or 100%. And that's just a good double check to make sure that you got everything right in the table. And then the last question here is, are the events of king on the second and king on the first independent? Why or why not? So king on the first draw, the probability of king on the first draw is 4 out of 52. The probability of getting a king on the second draw, well, if you got a king on the first draw, it's 3 out of 51. But if you didn't get a king on the second draw, it's 4 out of 51. So the probability of king on the second is not independent of king on the first, because your probability changes depending on what you drew first. So are they independent? No, they're not independent. The probability of king on the second changes or depends say it changes depending on whether you got king on the first draw. Or another way to look at it is to look at the probabilities. Look at what is the probability of getting a king on the second draw. What is that equal to? And then what is the probability of getting a king on the second draw? That's what the little 2 indicates, given that you got a king on the first draw. Okay, well, king on the second draw, there's 2 ways to do that. Either you got a king on the second when you got a king on the first, so that's this possibility, the 0.005, or you got a king on the second draw here when you didn't get a king on the first. So you either got a king here on the second or a king there on the second. 2 ways that are exclusive. So we're going to add those probabilities together. So the probability of king on the second is actually going to be 0.005 plus 0.072, which is let's see, that's going to be 0.077. But probability of king on the second, given that you got a king on the first, so it's given that you got a king on the first, probability of king on the second, given that you got king on the first, is 3 out of 51. So this is 3 out of 51. And that is 0.059. It's like 0.0588 if we round it 0.059. Okay, and these are not equal. Okay, so they're not equal, so that means that they are not independent or dependent. So they're not independent of each other. One event has an effect on the probability of the other. That's the general idea. All right, that should wrap it up.